Hi, this episode is all about node streams. A node stream is an extremely elegant mechanism which allows you to chain a bunch of modular processes together in an elegant way. Gulp is a good example of how node streams can help you to string things together. It's worthwhile to understand streams well, because you'll start recognizing all sorts of places where it's the correct pattern to use. Let's dive in. This code fires up a server. When a request comes through, it reads the contents of a very large video file and sends it to the client on the response. As you can see here in the terminal, this file is 1.2 gigabyte, so it's pretty big. We run this file with nodemon, so that our node process will be restarted when we update the app file. When we hit the server from the browser, we get a weird error. Looking at the console, we can see that it tells us that the file was too big for a possible buffer. Let's change this code to use a stream, which reads a chunk at a time and doesn't attempt to load the whole file into memory. We use the create read stream function instead and get a stream back. Response is a write stream, so we can just pipe the read stream to the write stream. Now when we hit the server, you can see that it starts downloading immediately, without loading up the file first into memory. Not only is this better for your server's memory consumption, the client also starts receiving data as soon as possible. So far we've used the built-in streams, but it's terribly useful and fun to write your own. I've copied a file with a whole bunch of words into my projects folder. This will give us something nice to play with. First, I want to show you how to code up your own read stream. The read stream will provide a random word to a downstream write stream. When you want to create your own streams, you need to require the stream module. I like wrapping my stream definitions in functions, so I call this one random word stream. The first thing we do in here is get a new read stream instance by calling the readable function on the stream module. It's a bit weird, but I'm not going to use a stream to read the contents of the file. I need to pluck out a random word from the file, so I need to have the whole file buffered. It's not a problem, because the file doesn't take up too much memory, but I just wanted to be clear that you should be using streams to read files when you can help it. We split the contents of the file into an array, so that we end up with an array with a word in each index. We want to be able to tell our custom stream that it should return only a certain number of words. So we define this variable to keep track of how many words we've returned already. We also need to take a max words parameter, so that we know when we've hit the max. When defining a read stream, you specify an _read function on it. This yields a chunk at a time to a downstream write stream. In here, we check whether we've already returned the max number of words. If we have, we push null downstream. This tells the consumer of the stream that it's done and that we've got no data left. If we haven't reached the max number of words, we start by incrementing our tracking variable. I'm doing the next part in a timeout, just to show you that the work in here can be done asynchronously. We generate a random number, which we'll use to pluck a word from the array. Finally, we push a word downstream. We also need to pass a time variable to the timeout function. 100 milliseconds is fine. To use this read stream, we need to wire it up with a write stream. Think of a read stream as something that knows how to get the data, and a write stream as something that knows what to do with the data. We get an instance of our stream, and we pipe it up with the standard out of the current process. When we run this, you can see it's happily piping random words to the process's standard out. It will keep on doing this forever if we don't stop it. When we specify a max words parameter, it stops as soon as it's reached the max allowed words. I want to show you how to code up your own write stream. So again, we define a function to wrap our stream definition. In here, we get a write stream instance by calling the writable function on the stream module, exactly like we did with the read stream. With write streams, you specify an _write function which takes 3 parameters. Chunk contains the chunk of data sent from upstream. Enc is the encoding for the data, and next is the callback we need to call to let the upstream know we're ready for the next chunk. We're not going to do anything fancy in here. We'll just log it to the console. This is pretty much what the built-in process standard out already does, but it's useful to see how it works. Once we've processed the data, we call next to let the upstream know we're ready for the next chunk. We assign our write stream to a variable and hook our read stream onto it. Looking good. If we remove the max words limit on the read stream, it keeps on piping to our write stream, which happily keeps on logging to the console. We can do some more fancy stuff to the message before we log it, by prefixing each one with a dash, for example. And of course, you can do async stuff in here as well, for example talking to a DB. When I change the next function to be called after a timeout, it still works. Let's increase that timeout to make it a bit more noticeable. We've coded up a read stream and a write stream. Now we're going to code up a transform stream. A very good real-world use of a transform stream is compression, but we'll do something a bit more visible here. Our transform stream is going to uppercase each word. To code up a transform stream, you need to call the transform function on the stream module. And on the stream, we need to specify an _transform function, which takes the exact same parameters as what we defined on the write stream. We convert the chunk to a string and uppercase it. We then simply push the uppercase chunk downstream. So a transform stream acts as both a read stream, providing data, and a write stream, consuming data. We call the next function in a timeout again, to illustrate that it's asynchronous in nature. We want to plug our transform stream in between our read stream, providing random words, and our write stream that outputs to the console. First we assign it to a variable. And now we can pipe from the read stream to the transform stream. Then we pipe from the transform stream to the write stream. Oops, I forgot to return the stream from the function. Cool! And that's it for this episode. We're gonna look at streams again in future episodes, but this should be enough to get you excited about it and allow you to code up your own streams. See you soon!